should be live, I'm not sure, but I think we're live. But chat is disabled. Why is the chat disabled? Do you guys have my voice? Oh, okay. Hey, yeah, you guys have my voice. Alright. Let me just fix the chat. Yeah, I know my voice is echoing. I had my laptop just playing the stream just to make sure everything is fine. So looks like everything is fine. Alright. So why is the chat disabled? Where is the chat settings? Let's settings. Our chat. Maybe live chat. Maybe show. Alright, the chat should be enabled now. Yep, the chat is live. Alright. So let's see. So I'm gonna start a series of why is this not incognito? It is incognito, alright. So I'm gonna start a series of streams like on code reviews of the Forge engine. So the Forge engine is maintained by 5 people right now. Yeah, Wolfgang is the main maintainer. So he's the main writer of the GPU Pro series. Let me see if I can find the book. GPU Pro book series. Oh god damn it. Yeah. So it's like this, yeah. This book series. So he's the main writer, Wolfgang Engel. So he's the main maintainer of the code. So I just cloned the code and started working on it. Not working on it, I just got it to build. So it is pretty straightforward. Like get the code and build, just clone the project. And to actually build it, I'm using Visual Studio on Windows as they recommended. Like here, PC Windows. No, where was it? Let me check. And where is it? Yeah, I have no idea where the build instruction was. I have no clue. Let me just search build. Use the right ending here. No, that's not. Oh yeah. No, no. God damn it. I don't know where the page is. Yeah. Here's how you build it. Just clone it. Get to the directory. Run the batch file. It's pretty interesting. The batch file just downloads whatever you need. You don't need to install like any other third-party stuff. So, and since I'm on Windows, I will just like open up the solution, the Visual Studio solution. I'm not sure if you guys can actually read that. Let me zoom in. So yeah, this is on their wiki page, the homepage, and yeah, you just clone the git, get to the project, run the batch file, and you can find the solution here. And you just open the solution. Here's my solution. So I'm using Visual Studio 2019. It's recommended by them to use 2017. So it is dependent on this SDK and the build tools. So it would be nice if I had line numbers. How do I add line numbers? So yeah, let's first just get an introduction to what I'm going to do. So I was recently introduced to the Forge engine, so I just started digging in and saw some codes. Like, it was pretty awful. Like the code right now I have here, it's example. I don't know, I don't have the lines enabled. Let's see how many lines this is. Where's my line number? God damn it, Visual Studio. Where do I get a line number on this? Come on. I need line numbers. Toolbar, no. That's gotta be on toolbar, is it? So let me see the chats, nothing on the chat. Alright. Okay, let me search out this. So yeah, from what I saw, the code quality was pretty awful. And that's why I decided to like do a code review, maybe improve on it, improve the code base. I also like to know what features they have and how they're implemented, since I've never worked on such big, larger scale engine. They have pretty good feature sets. So what that page told me is go tools options. Where is the tools? Ah, here. Options. Why should it be so fucking difficult? Just to get a line number show up. The options, text editor, all languages. Text editor. Yeah, this is kind of boring to watch, but hey, this is my first this kind of thing. Like, I've never done this kind of thing, so you gotta put up with me. Like, I have no experience on this, so I'm learning along the way. Well, let's check for all, I guess. Alright, here is my line numbers. So yeah, this is example code. This is like 4,700 lines of code, and lots of macros sprinkled all over the place. The code is pretty much not C++, and yeah, I will try to like wait a second, guys. Some backside for that. So yeah, the example code is like this. It's not that pretty of a code, like static stuff like here. I don't know, like the example code isn't that bad, but like the engine code I saw like on the rendering and stuff, it was just pretty awful. So I haven't actually read this example code so far. I'm gonna start reading on it. And yeah, uh, after I get some, like, I get to familiarize myself with the code, after that I will just start improving on it. I will probably clone the project and start like making issues on it and try to improve on it. So they have a Discord server, and I just like asked them where to start if I wanted to like get to know the code and start contributing. And they said like just read the unit tests, so that's what I'm going to do right now, starting from the unit test. So this is the unit test for Windows. I'm not sure if they are actually called unit. You can call them unit tests, like these are examples. I don't see any like actual tests. So yeah. And what else do we have here? So yeah, they have a Discord channel. Discord channel here. You can just join, and they pretty much respond well to your questions and stuff. Yeah, this is an interesting engine. So yeah, what I've done so far is just clone the, like, just follow these instructions on here. Where was down and just on the wiki page. I've just done this and got to build my project. Like I'm not gonna rebuild this, but you can just simply do those instructions and get the thing to build. The interesting thing is I couldn't run any of these examples. I don't know why, but I got one example built in and run it. So let me just get that example running. Yeah, it takes a pretty long time to load. I don't know why that is, probably because it's debug mode. It actually runs well. I don't know, the code quality isn't that good, but it works well. So yeah, that is the code. Wait, here. It's the material playground example. So it is a simple example, like nothing much in it. Let me just animate the camera. Yeah, there's this. Just that's all of it. You have a few options here, changing the material to wood, hair. That hair thing is interesting feature. I do like to know how they done that. So you could just play with these options here. It's not that much, but yeah, it's an example I've been able to compile and run. So yeah, this is what I'm going to start from. Like I'm just gonna try to learn what the example code does and what the interfaces are, and then I will just build from there to the code base. I will read the code base and see what that does. Uh, do whatever I think is better to do, like to improve the code base. And then after that, I will try to make pull requests, but I'm not sure if they accept any pull requests since they're a private company, and their actual Git is they have an actual private Git, and they just uh, push snapshots of that into the GitHub. So I think I'm already behind. Like they've just recently pushed to the GitHub after I've cloned it. So I will probably just do a pull after the stream. I'm not sure if they've actually done anything recently. Let me check again. Yep, they haven't pushed anything like since the last month. So they're probably gonna push like this month. I don't know, maybe not. So yeah, let's get to the code. I haven't actually read the code at all. Like it's the first time I'm reading this code. So yeah, let's start reading. Like 4,000 of 4K of code, 4K lines of code. It's gonna like suck, but hey, let's get to it. Where's my main? I'm gonna start from main, like see what they're calling, and I will like try to build from there. But there seems to be no mains. Is this ah, what is this then? Define application main. Material playground. So I guess this is ah. So they make a main from a class. Let's see what this is. This is the init part, initialization part, and it goes on and just collapse this. I'm not gonna read that much. Okay, this is the exit part, this is the load part. Who cares about the load part? Upload, what the hell is that? Update. This is probably the thing that is called to like update the scene or something. Alright, destroy samplers. No, no, no. Who cares about this and that? Destroy shaders. Huh. Have you heard of destructors? Use destructors for your shaders. Maybe that's possible. I don't know. I will just get to read and see if that is possible actually. I don't know how they've abstracted the shaders, so we'll get to know that too. How many member classes, how many member methods are there? Like, come on man. Destroy animations? Why the hell? Destroy typo. Come on. What is that? Public? You're still public? Jesus Christ man. Alright, this is your constructor. Such a nice constructor. Have you heard of initialization lists? I don't know, maybe that works. In settings, who knows what that is? Maybe it's in the IApp. The IApp might have just had a constructor of itself and help the child a little bit. I don't know. We're getting to know that too, I guess. So let's start from the init, I guess, initialization. Let's see what the initialization code does, because I'm not gonna read these, like, who cares what these are. Destroy render target. What the hell is a render target? I have no idea. Blah blah at UI exit. Yeah, that is it. Alright, so let's dig in then. I would like to also class these above. Who cares about these? Yeah, I hate these comments. Come on. No, no, I don't mind you, don't mind you. No, no, don't mind you either. Type diff enum. Yeah, that is very C++ right here. Enum class maybe? And why the hell type diff? You're doing C++, I guess. I believe you're doing C++. Yeah, that is uniform cam data. That's probably your camera data. Uniform. That's going to go probably into the GPU. And I'm not sure if this actually works. Like, it's probably like doing type tuning and stuff. I have no idea if this actually is going to work on real devices. It supports a large range of devices, like a plethora of devices. Like, look at this: PlayStation 4, PlayStation 5, Switch, Google Stadia, Mac OS, Android Pie with Vulkan 1.1. That is a large plethora of devices they support. So I guess the code works. I'm not sure how. Like, you probably are casting this into Voidstar or make something, just pass it into the shader. I have no idea how that works, but we'll get to that. So yeah, let me check this. Oh god, global variables. That is nice. Come on, man. Put global pointers. Null PTR maybe. And the list goes on. May God help us all. Alright, and what is this? A BB get vertex. Frosting. That's interesting. This is probably the Colin thing. Is checking whether axis aligned bounding box is in the frustum or not. So it takes a frustum and the name AABB and checks whether they match or not. I don't know what the AABB object is, but I'm thinking this is a copy, and that's probably gonna cost them some time, like some CPU time. You don't want to do that, do you? Yeah, so that is actually like six probably floating points. What is vector 3? Oh god, holy Christ. This is 128 bits integer. Since it's SSE thing, like this is SIMD, and they're doing weird things. Interesting. Let us not get carried away too much. So yeah, that is an interesting function. This can be reused like simply. But why is this not an engine feature? Like why is this in the example? That's interesting. Alright. So what the initialization function does, let's see. This platform uses boundary resources. What the hell is that? Oh, so this is kind of probably a kind of resource management thingy. I don't know. We get to that, but this is probably just loading this is initialization for loading the assets with the animation fonts, meshes and stuff in thread system. What is the thread system? I don't know. It's probably part of the, what is it part of? It's probably part of the IAP interface. So timer T. So what is this T used for? What a good name in there. Timer T. Oh come on, where the hell am I? Oh god, god damn it. So back we are. So is timer T at used at all? So I see this declaration, I don't see any uses for it. At least not in this scope where it lives. I guess I can just remove this. I don't know. Come on, no, no. I just want to remove a single line. What are you doing with me, Visual Studio? Let's run this. So far I've just removed one line of code from this. If that works, that is good. Like I'm hoping I can like remove several more. Yeah, that works. Like unused variable in your example. Nice. That is nice. Use your warnings, guys. Use your warnings. And it works. It seems to work. Like, yeah. That is your code right there. That is nice. And here we go again. We have an in-out variable. Huh? Why could this not be just a constructor for the render thingy? I don't know what the render thingy is. It's probably a pointer. Let's see. Yeah, this is a render pointer. And we of course give a pointer to the function, and it just sets it. I don't know why it couldn't return it. No idea. It sets the pointer. You check if the pointer is valid. So we could fail here. Who cares? Blah blah. GPU present level. I'm probably checking the GPU feature sets. So Q-type graphics. And type, I don't know what these are. We'll dig in later. CMD full descriptor. Command line full descriptor. I don't know. Add CMD, so it adds a command line to it. Yeah. Probably. I don't know. I don't know what these are. I will get back to them later on. So add fence. What is a fence? Yeah, I have no idea. They're doing some kind of like synchronization in their I don't know, graphics part. I have no idea what they're doing, like with those synchronization and stuff. So just adding a frames for some synchronization and stuff like that. I have no idea what that is. Probably this is also a pointer that's been initialized. Yeah, same with this. Return, guys. You guys can return from the function. It does return. It doesn't have to be void. And why is this CDecal? Like, you probably don't care about the performance here. CDecal, maybe this is a C interface. So I don't know. I don't know. I have no idea. I have no clue. I will dig into these later. See if these are actually C interfaces or not. But that still doesn't like justify why they're not returning a simple pointer and they're just getting an out variable, out parameter in the function. I have no idea. So yeah. And GLUA manager, that is probably their script manager. Of the scripting. Why is it in here? Why is this not part of the IAP? I don't know. Maybe the raw manager is not part of the IAP. Where is this defined? Ah, it is a global variable. Interesting. So what is the IAP thing he's providing for us? No, I don't want that. Domain. I have no clue. So I'm probably gonna also need to learn some like shortcuts for this. It's not a bad idea to learn some shortcuts for the Visual Studio via which I'm going to be recording these streams. It's not a bad idea. So I'm assuming this Vec2 thing is also, yeah, it was namespace seemingly. Let me see. Search online, no. Show me 5 overloads. Come on, man. Thank you, thank you, thank you very much. Alright, yeah. So what is this? GUI descriptor? Who, who cares? Like, who cares about the GUI? As a GUI component for simulation. So yeah, I will just mess about with these two. Like this is the easy thing, that just to like get to know the GUI system. So it seems pretty straightforward. So it shouldn't be that much of like that much. You shouldn't have that much overhead just to get to know the GUI system. And of course, we have a comment line of code that is nice to have in your Git. That's that's pretty good. Yeah, it seems like I'm actually really criticizing the code, but I do respect the guy. Like this guy, the Wolfgang guy. This guy writes good books. I have the fifth series of this. Fifth, I don't know if it's either fifth or no, it's the fourth. Yeah, I have this book. So it's a great book. I definitely recommend it. Go read them. So the book is like from several authors. The Each section is from a different author, and it just explains several rendering methods on each chapter. So it's a great book, but yeah, the code is awful. I wouldn't write this code. I wouldn't like touch this code. But here I am. I'm touching it. All right then. That is camera parameters. Look at this is the vector that the camera points at, and it's pointing at 0, 0. Is it the vector of where the camera points at, or is it like I don't know? Maybe it's the point. It usually is a vector, not a point, but who knows? Maybe this is the point because vector of length 0. I will initialize my camera with that. Create first-person camera controller. Creates a camera right there. F3 TOV3. What the hell is that? Interesting. Ah, ah, ah. What is this? F3. Create UI camera controller. No clue. This is something I will also get into later. So yeah, it just creates a camera right here. Camera controller is passed here. Camera controller. So you have inheritance here, and you like to use this code in C, no, no, you don't. You have inheritance here. Don't do that, please. No, no, this is not the C interface. You shouldn't be using cdecls, right? Don't use cdecls. I have no idea why you're using cdecls. Like vector callback calling convention is like way faster. Like check this. So this was first called fast call calling convention. So what it does is to like put all the parameters into the registers. Like the fast call version has like 4 registers, I believe. So cdecl is the C declaration, C calling convention, and it just straightforward puts everything into the stack. So that is how you're actually getting the variadic parameters on varix. That's what it's called in C. Uh, it just pushes whatever you pass in the parameters, and it just pushes it in the stack. And when you pop, you can pop whatever you want. So that way you can actually get to like stack overflow, underflow. So let's go Godbolt here. It actually loads up. So yeah, here's our Godbolt. Like what this does, this uses cdecl. So what this actually does when I'm calling it, probably let's not call the square foobar. That's our thing right there. Okay, I'm calling foobar with like 1, 2, 3, 4. Who gives a damn crap? So here's it. It's just like here, pushing everything inside. Actually, this is actually using vector call. So let's do this cdecl. Is that how it's here? cdecl, yeah, that's use cdecl, return type cdecl. Okay, I should move. Oh no, 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 no! I'm not making my main cdecl. I'm making foobar cdecl. So this is my cdecl here. Let's see if it compiles. It doesn't compile. Why does it not compile? Foobar was not declared in the scope. So it says I'm not. I don't want your cdecl here. Why does it not want my cdecl here? Huh. Come on, dude. I want cdecl here. Initializer before. What is? Ah, come on. Oh, no. It here. That is it. But why does it not work? This should work. This is common C code, isn't it? Return type cdecl. Maybe this is because I'm using still using GCC. That's a kind of weird here. Let's see what MSPC does with this. This looks pretty straightforward. I have no idea why this is not compiled. Does it name it type cdecl? Let's search this, right? Shall we? cdecl in GCC. Let's see what this is. cdecl in GCC. The parent specific this blah blah while Linux rejects it. Blah blah. That is we need to do this attribute cdecl. I'll do that then, I guess. Why wouldn't I? Is this going to work? Yeah, and I get some warnings. I do not return anything. Let's make this void. I don't care. Here we go. What is this? You attribute cdecl attribute ignored. Ah, thank you. Thank you for my attributes. That is nice, I guess. Well, whatever, it doesn't matter. So far, let me see how far it's going to like uh, put these in the registers. So yeah, it started pushing to this stack from there. Like it only supports like eight inputs. Is it 8? That is 7. So probably one is, I don't know. Why do they have 7, not 8? Just, yeah. So this is actually like, so C++ doesn't have any calling, any standardized calling conventions. It just uses whatever your compiler decides to use. So this is a kind of vector call. So the vector call, let me see if it is here, vector. Yeah, it's here, the vector call. Just kind of like Pascal. It was first Pascal and then it turned to vector call. What it does is to just put whatever it can into the registers. Of course, accessing registers are way faster than accessing the stack here. So it just tries to push whatever it can into the registers, and after that, if it fails, it just, yeah, it doesn't have any more registers just to put in. It uses the stack, and on the CDeco way of doing things, it just pushes everything into the stack from the beginning, and when you get into the function, you just pop from the stack to get your variables. So if you like declare foobar and use more than what you've actually pushed into the stack, you're going to do a stack on the flow. So yeah, that's it. So we're 37 minutes in, I guess. Are we? Are we still live? I hope we are. Seemingly we are still alive. Yeah. So yeah, I hope you're alive. So that is what the underflow is. Am I recording this? I don't know. Is my huh, interesting stuff. So yeah, they're using CDecal. I have no idea why they're using CDecal. Stop using CDecal. There's no reason to use CDecal. I don't know which one was CDecal. But don't use CDecal, don't use macros either. Don't use any of this. Alright, there were we. So I guess I just removed a single line. That was the whole point of this, I guess. I'm just gonna like make sure the stream is going on. My laptop just got disconnected, so I'm not sure if the stream is still playing. Oh no, seems like it is not playing, is it? I seem to have internet here. My encoder says it's streaming. I'm just hoping it is streaming. Wait for my connection to get back. Thank you. Wow. Also, we are indeed live. Alright, that's good, that's good. Let's go on. Let's go on. We have 20 more minutes to do this. Let's finish what we've started. Alright, let's try to finish this one function, the initialization function, I hope. So yeah, we are like, okay. So these were some fences, some semaphores, whatever. We got to the camera, they're doing the camera here. And there we go, the set function. What is it? What is this path? So what does this do actually? This is the Lua manager thingy. This is the script manager thingy. They're doing Lua scripts. And alright. So yeah, the set function, Lua manager, set camera position, set get camera position. So these are the functions that are probably called by the Lua manager to set the camera functions. It set the camera positions and stuff like that. So this is the part that's actually interacting with the camera, probably moving the world. Like when you're moving the world, it is probably called by the Lua script and just sets the camera. Interesting stuff. So this is simple. Update camera path. Huh. So path handle. If this copy path, your resource directory, middleware, whatever. I don't know what these are. Probably it's just like set something just to like when you set, enable the animate camera feature. It probably uses this to find what uh, the path of the camera is going to be. So it probably uses this and Lambert reflection. Oh, okay, we're onto the materials. So material mill. What does it do? Get material lighting model map. Interesting. What is this? Where is this defined? ASTL. So this is part of the library, I guess. The library they provide, I believe. No. Ah, just an unordered map from material type to diffuse reflection model. Interesting. Interesting stuff. So why is that? What the hell does any of these mean? Diffuse reflection model, I know what that is. Material types, I don't know what they are, but they're probably just material. It's enumeration of the material types, I guess. Interesting. Interesting stuff. So just setting the diffuse uh, diffuse material type for each material type probably. Let's get back to the class. We're back here. So it's just saying that for metal material, I want Lambert reflection. For wood material, I want Oren-Ney reflection. You can just easily check the Wikipedia for these to see what they actually are. Again, Lambert reflection for material hair. Interesting. These are actually, where are these actually defined? These are actually defined by ourselves in this example. I don't know why is everything just declared in this example, but it seems to be. Okay, init input system, that is the input system. Tries to init it on this window. Where was the window initialized? So I guess the window is initialized by the IApp, because I have no it's the first time I'm seeing the window p window thingy. It could be a member. Member, I don't know, it's not a member, doesn't seem to be a member. I don't see any p window members here. This is probably just what we've inherited from IApp. I don't know why it doesn't have IApp before it. I would use it like that. I'm not sure if this is a member. P window, this could be, yeah, this could be global. Don't use global. It is just so. Oh, it is IApp, and the IApp is in this. Oh yeah, it is IApp. It is part of the IApp. Okay, IApp is what the library provides us. I would just do this. It makes the reading just a lot easier. And your C++ anyways, where you just trying to avoid C++, this code is not going to compile anywhere but C++, so just get on with it. Get it completely C++. Alright, so action descriptor. So this is probably saying that if this action happens, do this, and if that action happens, do that, blah blah, goes on. Action descriptor button any. So this is what happens when you push any button. Alright, add input action, blah blah, it just adds input action, so and it's going to respond to it, to whatever action it's necessary to do depending on those commands. But I would like to see what this actually correlates to, corresponds to in the application, because I have no idea what this is, what this actually does, what the feature is. So I would like to see this when executing the example. I will try to dig in and find how to do that then. And here's the Lua manager. I'm not going to dig into this. This is pretty straightforward. I don't know where the Lua scripts are loaded from. Let's see if there are anything. Okay, nothing here. Interesting thing is this fs append. So I guess the fs stands for file system. Append path component program directory. So this is probably the current directory. Interesting. And resource directory. Okay, I don't know what that is. So I'm not sure if this is at all like confusing or not. The initialization function is pretty straightforward. I will have to dig in more to some of the easy stuff. PBR maps. What is this? Compute PBR maps. Create shaders. That is some interesting stuff we're going to dig into. This is actually a member function, as I remember. Oh yeah, these are the member functions. Why are these not private? These are not called by anything. And yeah, this is probably like virtual. We're overriding. I'm pretty damn sure we're overriding IApp. Let's see this. So this is, yeah, we're overriding virtual from the IApp, the exit, the load, upload, unload. Oh, unload, not upload. So I've been reading this upload. Yeah, my bad there. And update draft. These are the interfaces we need to make public. Why are we making everything public? Put a goddamn private here. Yeah, from here on, these are private members. You don't need to implement them. These are used only by us probably. So no need to actually make these public. I guess I could just put a private here. Is this going to work? Let's see. So that works. Alright, we're already making the code better. We've removed the line. And we've made several member functions private. That is good. I don't need to read these to know what my application does. And you could probably put an override here. Some people and final as well. Okay, not override that there, but here. Wow, stop debugging. What the hell is that? Yeah, stop debugging. I don't know why you're asking that, but override. Override. I was right. First time I was. Okay. I would like to also do virtuals. I know Jason Turner recommends that you remove this virtual, this override thingy. That final just implies virtual, implies override. I do like seeing virtual on my virtual functions. Like, I don't care about this final. This is what comes at the end of the function. I see this virtual. I know I'm overriding. Virtual here. Not here. No, not override here. I know many people just would say don't use all these together. At the end, what did you say? No? Am I? Okay, that's fixed. Alright. So I like this. Many people in the community would say to this. Well, that is simpler code, but I don't know. Maybe this is better. I'm not sure. I prefer this though, and I'm going to stick with that. So these are the implementations we're going to look first through this series and just figure out what they do. And for the next time, I'm just going to like mark a few of these functions we didn't dig into, and I start actually digging into them to get some general idea. I'm not going to read the whole code of these functions. I'm just going to get some general idea of what they do. Some of these things I know what they do, like virtual joystick initialization. I don't care for this right now, but I don't care for it. I know the general idea of what this is doing. The name is pretty good. I don't know. I don't know about that timer T thing we just removed from here, but the rest of the namings are alright. They're not the best, but alright. And yeah, I will just make a list of the functions I'm going to dig into. Like probably I would like to see what this create shader thing does. That's interesting. This is my member function here. That is an interesting function. I would like to see what this does. And it's not that large either. So yeah, this is seemingly just loading the shaders. I would like to see what their shaders are. I will also dig into those. I don't know if this is going to be interesting for everyone. Some of my viewers would be probably just interested in the C++ things I'm doing. But yeah, this is a graphics engine, and I'm going to dig into these things like the fragment shader, vertex shader. I saw some compute shaders here. This is for the hair thingy. And yeah, these are interesting stuff. I'm definitely going to dig into them. And there we go. I'm probably going to dig into these the next time. And some of the functions I just skimmed over here. I didn't actually get deep into them, like what they're actually doing. I'm gonna get a little bit deeper and see what they are. So I'm planning to like do an hour a day on this. So probably the same time as this one. I'm going to put an hour a day and yeah, keep digging into this code base. The code base isn't that great, like CStarCast. No, my friend, no CStarCast here. But the code works and the result is fine. So let's get the code better, I guess. That's my goal here. Make the code better, probably going to run better. So one interesting thing that I just realized, we saw an ABB function, ABB in Frostum function. Where is this one used? Huh. So is this actually telling the interesting stuff. Interesting. So I guess it's stopping the animation when it's stopping the Frostum? Is that what this is doing? Citrus transformation. So for those who doesn't know what this is doing, so let me just Google you a Frostum. So Frostum is a part of the pyramid, part of the pyramid. This is called a Frostum. This is like the camera Frostum right here. So what your camera sees is the area in this Frostum. So an AABB is the axis aligned bounding box. Not this axis aligned bounding box. So yeah. So what an axis aligned bounding box is, it's just the box that aligns with the axis and it just contains the object completely. So what that function does is to check if this bounding box collides with this frustum. So if any of that bounding box collides with this frustum, it's probably inside the camera view. So from that, it will just decide whether or not could decide whether or not draw the object or animate it. I guess here it's just decided not to animate it. Yeah, animation not updated. So what it does is to check if the camera is seeing the object